All right, guys, one more way to solve quadratics. Last week we talked about solving by square rooting, and we also talked about solving by factoring. But when you can't find the factors real easily, or when it just doesn't factor, then we have to use what's called quadratic formula. The quadratic formula says for any equation where you have ax squared plus, that can be written in this form, okay, ax squared plus bx plus c equals 0, and remember it must equal 0, then what you can do is solve for x by doing this: the opposite of b plus or minus the square root of b squared minus 4 times the a times the c all over 2a. And again, that works when a is the coefficient of x squared, b is the coefficient of x, and c is the constant term when it's equal to 0. Now, I'm going to write it out over here one slightly different way. I'm going to say you can solve for x. Well, solver, I don't know what I'm doing. Solve for x. Again, it's the opposite of b plus or minus the square root of. Now, when you're doing this in your calculator, it's really important. If b is negative, you absolutely have to put these parentheses in. And the squared goes on the outside. So it is b squared, and then it's minus 4 times a times c, and you're going to multiply all those things together before you subtract. And it's all over, and you have to do 2 times a before you can divide. All right, and if you were doing it in your calculator, you could do a whole extra parenthesis there, but I highly recommend you do this in a couple bits and pieces. All right, moving on to, since I know you've seen this before, I'm just going to quickly get into some examples. I will leave this slide in. And in this slide, here's an example worked out, okay, with some color coding and some parentheses, and you will notice it came out 109 in here, and so they ended up with 2 solutions, and this is generally how we would leave our answers for pre-calc, okay? Now, this one had a negative b, and it had a negative a. So the opposite of b became positive 6 down here. And then when they did this inside here, it became 68. Now, 68, I think, is divisible by 4. Let's try that. Yes, 68 is 4 times 17. So in pre-calc, we would have said the square root of 68 is the square root of 4 times the square root of 17, and the square root of 4 simplifies to 2, so we had 2 square roots of 17. So we would have said this is 6 plus or minus 2 square roots of 17, and then it's over negative 2. I'm going to write the negative 2 under both of those so I don't do any silly thing like cancel it with 1. And that will give me negative 3 plus or minus, this reduces to negative 1. You could write negative 1, but plus or minus a negative 1 is the same as 1 square root of 17. Half power, you're in the way. So let me write it as a negative 1 there. But when you rewrite it, plus a negative 1, it's just minus 1. And minus a negative 1 is a plus, so it becomes this, okay? That's how we do it in pre-calc. All right, let's try some. So here A is 1, B is negative 3, and C is negative 70. Lovely numbers. So the quadratic formula says the opposite of B plus or minus, that doesn't look like a parenthesis, does it? The square root of the b squared minus, remember the 4 comes with the formula. It's the only one we don't put something in for. Well, there's a 2 in the denominator too. Not the only one. 4 times A times C all over 2, which again came with the formula, times A, which is 1. All right, all of this is what x equals. Opposite of negative 3 is 3, plus or minus. All right, we can type that part in the calculator. If we do parenthesis negative 3 parenthesis squared minus 4 times 1 times negative 70. I didn't type the negative or the 1 in because I know that's not going to matter. And I get 289. And in the denominator, 2 times 1 is 2. Now it just so happens I recognize the square root of 289 is a perfect square. I believe it's 17. So the square root of 289 is 17. And so if I tried to simplify that, I would have figured out that 17 went in there. Maybe. It's pretty far down the list of numbers. But so on the top, because it was a nice positive number and it happened to be a perfect square, we got 2 nice real solutions here. So 3 plus 17 is 20, and 3 minus 17 would be negative 14, and those are both over 2. So our solutions are 10 and negative 7. Now, because that came out nice, it meant it would have factored actually. All right. Moving on to number 4, got real little numbers this time. A is 1, B is 1, and C is negative 1. So this one is going to be kind of weird. The opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Well, won't need a calculator, I'm thinking. Square root of 1 is 1. Minus 4 times 1 times negative 1. Be really careful, guys, because so many people make a sign mistake here. Minus a 4 times 1 times negative 1. Well, this is a negative 4 when you multiply it all together, so minus negative 4 becomes plus 4. So if you type that in your calculator, you will get 5. It's 1 plus 4 because the minus and negative cancel each other out. And it is all over 2. So you could leave it like that, or you could rewrite it as negative 1/2 plus or minus the square root of 5 over 2. All right. Number 6. A is 3, B is negative 4, and C is 6. I have a feeling we're going to have a little bit bigger numbers this time. So the opposite x is the opposite of B plus or minus the square root of B squared. Now, if you don't put those parentheses in and you type negative 4 squared on your calculator, you all know this, right? Negative 4 squared. The order of operations are to square that and then take the opposite. If you really want it to square negative 4, the whole number squared, you have to put it in parentheses. Please don't get that wrong. And then it's minus 4, the 4 that came with the formula, remember, times A times C all over 2 times the A. So I get 4 plus or minus, I'm thinking I should go to the calculator here. All right, so negative 4, I'll show you with the parentheses again, squared minus 4 times 3 times 6 is negative 56. I wonder why the lesson right before this was imaginary and complex numbers. Okay, all over 2 times 3, which is 6. All right, we have a lot of simplifying to do here. We're going to have 4 plus or minus. The square root of 56 is the square root of negative 1 times the square root of 56. But the question is, does 4 or other perfect square go into here? Remember, our perfect squares are 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Any of those divide in here? I believe 4 does. So if I take 56, which I already divided out the -1, and I divide it by 4, it does come out evenly as 14. Now 14 is 2 times 7, but is 2 or 7 a perfect square? Nope. So we get to just leave it like this. The square root of -1 will be I. The square root of 4 will be 2. And the square root of 14 we have to leave because it's irrational. And this is all over 6. Now, we never write it this way in math, I times 2 times the square root of 4, because we always get concerned that somebody's going to think it's a plus or minus somewhere. So we just rearrange those and write 2i square roots of 14. And I'm going to separate this so we don't do any silly reducing. We write it as 2i square roots of 14, which I did not write neatly. Let me try that one more time. All over 6. Now I can reduce and not do any silly canceling that I shouldn't be doing. This one will reduce to 2/3, plus or minus 2 into 6 is 1/3, I square root of 14. Okay, you can write the 1 there if you want. Okay, if you had left it as a combined, it would have been 2 plus or minus I square roots of 14 all over 3, after you reduced every part of it by a 2 right up here. Okay, we divided out a 2 on all these parts. Notice the radical never reduces because there's not another radical to reduce it with. All right, do I have one more practice on this? Why won't my slides move forward? Okay, ooh, they're trying to trick me. This does not equal 0. I hope the last ones all did. Okay, almost thought I got caught. So I have to make it equal to 0 first. So I like a positive a value, so I'm going to add 9x over to this side. And I'm going to subtract the 8x over to that side. And there's already a 4 over there. And that will leave us equal to 0. So you can write out your steps if you want, but when we added the 9x squared to the other side, it became positive. We subtracted the 8x over there. So now I have my a, b, and c. So I'm going to jump right to the quadratic formula. X equals the opposite of b will be 8 plus or minus the square root of b squared minus 4 times a, which is 9, times c, which is 4, all over 2a, or 2 times 9. All right, so I have 8 plus or minus, let's see, parenthesis, -8 squared minus 4 times, and you really can just do times down here, times 9 times c was 4. So I wound up with a -80 all over 18, 2 times 9. Now, we got to simplify this guy. We end up with an 8 plus or minus. Okay, there is a square root of -1 in there. There is a square root of 80. Well, the square root of -1 is I, but 4 goes into 80 20 times. We could do that, but this would break down again as a 4, right? Which tells me that something bigger actually went into 80. if you look at your list of perfect squares, I believe 80 is actually 16 times 5. Okay? And you could have done this twice, guys. You could have said, well, the square root of 4 is 2, and then I still have square root of 20 in there, and the square root of 4 here is a 2 again, so I end up with 2 times the square root of 5. Or if you figured out 80 is 16 times 5, you get 4 square roots of 5. All right, so don't forget there was an I because it was a negative 80, and then we had a 4 square roots of 5. So I'm going to write that as 4I square roots of 5, and it's all over 18. Now remember, you have two choices. You can very carefully remember to reduce all these by 2. Or you can separate them. 8 over 18 will become 4/9, and 4 over 18 will reduce by 2 to 2/9, and there's an I square roots of 5. All right, very carefully, this is two solutions. Everybody's good on that, right? One is a plus and one is a minus. These are complex or imaginary solutions. They are non-real solutions. On the one before this, we ended up also with imaginary, so we had non-real solutions or complex. On the one before this, come on, we ended up with a positive square root of 5, so this had two real solutions. One was plus square root of 5 over 2, and one was minus. So two real solutions. And before this one, we had two very nice solutions, but because this was a positive, we ended up with two real solutions. Because it was a perfect square, they were nice rational numbers. All right, so the idea is that we can predict ahead of time whether we're going to get real or non-real solutions. We get real solutions when we had a positive number in the radical, okay? So if we do negative b plus or minus a positive number in here, then we ended up with two real solutions. What that means is the parabola crosses at two real places the x-axis. It has two real x-intercepts. When we had a negative number inside the radical, okay, then we ended up with imaginary solutions, which is this, okay? Inside of here, we wound up with a negative number. That meant we had imaginary solutions, which would mean the graph did not ever have any x-intercepts. It didn't ever cross the x-axis. The other option is we can have one solution only. You know what? I don't even know if I have one of those. I skipped a question here. I wonder if this one came out that way. I don't think it did. All right, if the discriminant had turned out to be 0, we would have wound up with only one solution. In other words, if we had found an equation where it was x equals -3 plus or minus, and all this came out to be 0, we would have wound up with only one solution because plus or minus 0 is 0. So I didn't have a good example of that. I apologize. But when what's underneath the radical here, I'm having so much trouble with this slider. There we go. What's underneath the radical is simply a 0. Plus or minus 0 doesn't do anything, so we wind up with one solution, one x-intercept, and only one solution. Okay? It is one, it's called a repeated root because it would, if you factored it, it would come out as a squared. But it's one real solution. Okay? So, back up to the questions here really quick. It says, what kind of solutions did we get? Well, we had either real or complex. The real could be rational or irrational, but that's all we cared about. And can we predict this ahead of time? Yes, we can use what's called the discriminant. The discriminant is what is under the radical, but it doesn't include the radical, okay? We just use this part. And it tells us if that discriminant is positive, that we will have two real solutions. If that discriminant is negative, when we square root a negative number, we get imaginary numbers, so we will have two complex solutions. It means it has no x-intercepts. And if the discriminant happens to come out to be exactly 0, then we get only one real solution because plus or minus 0 doesn't matter, it's only one solution. And how do these relate to the graph of the parabola? This one meant there was two x-intercepts. This one meant there were none. And this one meant it only hit the x-axis once, or the vertex was on the x-axis. All right, so real quick, when you look at this, you have A is -2, B is -4, and C is -2. The discriminant, remember, does not include the radical. It's just B squared minus 4AC. So the discriminant will be -4 squared minus 4 times -2, because that's A, times -2, which is C, which is 16 minus. This becomes 4 when you multiply these two together. This B is a 4, so we get a 0 for the discriminant. It says, what is the discriminant? Then state the number and type of solutions. So the discriminant is 0, so there is only one solution, and the type is, it is a real solution or real number. You can just write one real solution. All right, number 15, yuck, A is negative again. So if we do the discriminant, remember B squared minus 4AC, no square root. 9 squared minus 4 times -6 times -7. Well, this is 81. This part right here is 42. So we get 81 minus 168, if I did that right in my head, is -87. Let's try that on the calculator. It was 9 squared minus 4 times -6 times -7. I skipped the parentheses around the 9 because it was already positive. I did get -87. Okay, so the discriminant is -87. That means there are two complex or imaginary, non-real solutions, and our parabola would not cross the x-axis at all. All right, last question, I hope. Yes. We got to be real careful on this guy because it doesn't equal 0. They're trying to trick us. We got to subtract the 2 over so that we have A, B, and C. So the discriminant is b squared minus 4 times a times c would be 9. Let's see, this would be negative 4 times this is a negative 4b plus 16. Get 25 is the discriminant. All right. Now, because it's positive, we would have 2 real solutions, or 2 x-intercepts. Did I still not get one that was 0, or did I end up? Yeah, we did. Okay, so I did one of each kind. All right. Again, the quadratic questions you're going to have to do are going to be in Delta Math. I will go back and do the odds or the evens on the notes if that would help you to practice on paper or to see more examples. Before I post the notes, I will finish those. Thanks, guys. Have a good luck with this.